Okay, we're moving on up. And now the next piece that we need to talk about with the GC is what comes next. Well, that's my columns inside of the machine. And the columns inside of the machine is really the magic. That's where all the separation takes place. So my sample gets injected into the machine, but it goes into the column, and the column is the tunnel that begins to separate all of my components from each other. So we need to talk about the different types of columns, and we need to talk about how they work, and we need to talk about maybe some variety that I can have with my columns to do a better job for me in the method analysis or in my laboratory experiment. Okay, so the very first thing, we've already talked about it over and over and over, is that there's two major types of columns that we would see on the GC system. And the first one is what we would call packed, and the second one is what we would call capillary. And packed is the old school one that used to be used, and capillary is the most common one that's still out there in today's environment that continues to get used. And honestly, it probably will not go away for quite some time. So you're not really going to see a packed column hardly anymore at all. You're going to see capillary columns whenever they come through, and that's supposed to be a P. I know my handwriting's horrible and I apologize, but that's supposed to be a P. So GC systems, uh, it's very common though for them to be still be modified to hold a packed column if that's really what you need. But honestly, it's going to be capillary almost every single time. The packed column on the inside, why do we call it packed? Well, it's basically a tube, and this tube is filled with stuff. Traditionally, a white looking powder that goes on the inside. All right. And this white looking powder has a name, and that's typically called chromosorb. This chromosorb is what we would refer to as the stationary phase. Stationary means it stays put, right? So stationary phase means that this stuff is not going to go anywhere. What happens is that my sample is squirted into the GC system. And after it goes through the injector port, it then goes into the column. And this stuff begins to get held up inside of the column itself. And what holds it back is something that we call stationary phase. And this stationary phase, we have a term, and we traditionally refer to it as chromosorb when it concerns a packed column. Now, capillary columns are made a little differently. Capillary columns, you still have this tunnel, but it's not completely full. It's not completely filled. What happens is that in a capillary column, you traditionally have the stationary phase on the sides of the wall because these are very thin to begin with. They're not very wide for your sample to go through. So if they just coat the layer, the inner surface, with stationary phase, what happens is that your sample still kind of brushes up against it as it flows through the machine, and it will get lagged and stayed behind. It will get held up. So that's the difference between the two types of columns. Packed is completely full of stuff. That's why we call it packed. Capillary, in a way, has this hollow internal diameter, if you want to think of it that way. And the stationary phase is smeared along the internal walls of the column. And this is what reaches out and grabs a hold of your sample and holds it back throughout the analysis. If we want to talk about dimensions here for a minute, for a packed column, The dimensions are typically about 1 to 3 meters long. All right, so a meter is about the distance between the floor to your waist. And if you took that 1 to 3 meters and you curled it up, because this is still curled, right? It still goes round and around and around and around in the machine. That will stretch out to be about 1 to 3 meters. The things are very wide as well. Packed columns traditionally have anywhere between a fourth to an eighth of an inch in width. 1/4 to 1/8. Well, that's why they can take a lot of sample. And that's why you don't really need to split your sample up in terms of split or splitless. You can just directly inject it onto the column and directly vaporize it and let it go through the column itself. The flow rates for these things, because they are much larger columns in dimensions, can go anywhere between 10 to 40 milliliters a minute. All right, and that's a lot, especially when you start comparing it to the capillary column, which we'll do in just a second. Chromabsorb. What is Chromabsorb? I mean, this is kind of a registered trademark name in a way. There's got to be something with Chromabsorb, though, right? What exactly is it? It's a lot of times, not every time, but a lot of times it's something that we refer to as diatomaceous earth. Okay, now if I wanted to spell that, Diatomaceous, diatomaceous. Diatomaceous earth are basically little algae critters that have very high surface area, which means these are particles, and the particles are very tiny. And these particles are filling these packed columns as powder, filling the column with stationary phase. And my gas goes through those spongy-like particles as it travels through the column. Diatomaceous earth is very light and it's very fluffy. So if you are working with it in the lab, and we have some, if you take the lid off of the jar, it's a very light powder, almost kind of like flour in a way. If you slap flour onto the counter, you see it go poof. And the same thing happens with diatomaceous earth. So these things are like little sponges, and there's openings and craters in them, and your sample goes through all of those little openings and crevices slowly, little by little, as it travels throughout the column. Okay, so now let's talk about the capillary column. How's the capillary column any different? All right, well, instead of 1/4 to 1/8 of an inch in width, these things are typically 100 to 530 micrometers wide. That's very tiny. And again, we always refer to it as the width of a strand of hair. That's how tiny these columns are on the inside that your sample will pass through. So 1/4 to 1/8 of an inch is pretty large compared to 100 micrometers. Again, micro means a million, right? It's 10 to the sixth. This is a millionth of a meter. Super, super tiny. And that's why you cannot have a lot of sample that you inject onto these columns. Now, how long are they? Well, a packed column is anywhere between 1 to 3 meters, and a capillary column is traditionally anywhere between 30 to 100 meters long. 100 meters. That's crazy talk, right? I mean, imagine the distance between the floor to your waist and then multiply that by 100. And this thing is curled up on the inside of the machine, and that's what your sample will travel through. Super, super tiny, or super tiny in width, but super, super long in length. Something else that we need to talk about as far as the differences between the column. These are traditionally stainless steel on the outside. The capillary columns are traditionally glass. And it's glass with a special coating on the outside. It's a polymer coating. These are thermally stable. That way it prevents the glass from breaking or snapping as they coil it around, and it gives it some reinforcement. So capillaries glass, packed is typically stainless steel. Okay, out of the two, capillary is used the most, and therefore in the next video, this is what we're going to be focused on in the GC world. Packed is out there. We can mention it just like we did here, but we really want to place a focus on capillary columns because that's what we'll see most of.